Hello everybody, my name is Roman Rodrigues and we are doing physics. We are on chapter 10, heat, and this is lesson 4. And today we are going to discuss about expansion of gases. And we'll try to cover up these two laws, Boyle's law and Charles' law. Okay, first let me just explain to you what Boyle's law is all about. Now, Boyle's law was this law was put forward by an English scientist, Robert Boyle. And he stated, I'll just write down the statement. According to Robert Boyle, the volume of given mass of gas is inversely proportional to pressure, provided the temperature is kept constant. Now, it means at constant temperature, the volume of a given mass of gas is inversely proportional to pressure. So mathematically, I can write it down as volume is inversely proportional to pressure at constant temperature, and this alpha is the sign of proportionality. And if I remove the sign of proportionality, I'll have to put a constant K, and upon cross multiplication I get PV is equals to K. PV is equals to K. Now I can understand it by means of this figure. Let's say you have a container, okay, and this is the volume of gas, V1 initial, and the pressure over here is P1. So when I increase the pressure, okay, when I increase this pressure, what will happen? The volume, if I double the pressure, the volume will become half, in other words, okay? So it's inversely proportional, less pressure, more volume, more pressure, less volume. So as you know, the volume is inversely proportional to pressure. This equation can now be also written down as, if you're comparing it with the initial and final pressure and volume of a gas. So I can say if P1 is equals to the initial pressure of gas and V1 is the initial volume of the mass of gas, and P2 is the final pressure of gas, and if V2 is the final volume of gas, then our equation will be equals to P1 V1 equals to P2 V2. So this is what Boyle's law is all about. Now let's move on to the second law, which is Charles' law. Now this law was put forward by a French scientist, Jacques Charles, and according to Charles, let's write down here, Charles' law, the volume of given mass of gas is directly proportional to temperature, provided pressure is kept constant. So mathematically we can say that volume is directly proportional to temperature. This is at constant pressure, and alpha is the sign of proportionality. When I remove this sign of proportionality, I'll get kT. K is your constant of proportionality. So you can write this down as V is equals to kT. You can understand it by means of this figure, that let's say this is your initial volume of gas. Pressure is same, constant. Now if I increase the temperature, okay, this is say room temperature, if I increase the temperature, heating it or whatever, T2, what will happen? The volume will increase. The volume of the gas will increase. The pressure remains the same. Okay, pressure remains the same. So if V1 is the initial volume of gas and T1 is the initial temperature of gas at constant pressure, and V2 is the final volume of gas and T2 is the final temperature of gas, then our equation will become V1, if this is V is equals to kT, I bring T on the other side, I get K constant of proportionality, V1 T1 is equals to V2 over T2. This is the final equation for Charles' law for volume and temperature when pressure is kept constant. I hope it is clear. There will be a combined gas law in the next lesson where I'll combine these two laws and then derive an equation, and we'll also be solving a few problems based on Boyle's law and Charles' law. Till then, take care.